Hello everyone and welcome to our webinar today in partnership with Solo.io, where we'll be showing how GitOps can be used for setting up your service mesh to avoid a service mess. Before we begin, I'd like to mention a few points. Today's webinar is being recorded and we'll be sharing this with you and together with the slides tomorrow. All participants are in listen-only mode. If you'd like to ask questions, please use the Q&A panel at the bottom of your Zoom menu, and we'll address those at the end of the Q&A, at the end of the session, sorry, during the Q&A. So with that, I'd like to introduce you to our speakers today. Steve Waterworth, he's a technical marketing manager at Weaveworks. He's been in technical roles in the app performance management space since 2004, where he has seen numerous technical revolutions and market disruptions, giving him a unique insight into the rapidly changing DevOps environment. And then we'd like to welcome Daniel Wessels, a field engineer from Solo.io. Daniel has been busy over the years in various platform roles, and since moving to the cloud, he's wanted to see how to make it as boring as possible for enterprises. This journey has taken him from building physical enterprise e-commerce infrastructure to doing the same in the cloud-native ecosystem. And now I'll hand you over to Steve to begin.
Hi there, thanks for joining. Hopefully you all managed to, all those Americans amongst the audience managed to set the clocks the right way. Europe and everybody else is still catching up. So a little bit about Weaveworks. We have a number of customers across a broad range of verticals. We are key technology partners with all the major cloud providers. We contribute to and maintain and have donated many open source projects, and we're backed by a diverse range of solid investors. So building better code faster, this is really sort of at the heart of the digital transformation. Everybody's trying to get new features and fixes out the door as quick as possible, because if you're not doing it, your competitors are. And using service meshes is part of that rapid deployment. It allows you to do so many cool things that would be very difficult without one. But of course, service meshes are complex and difficult to manage, lots of YAML files. So how can we make that easier? The answer is add GitOps, and that is what this is all about. So let's dive in. So the principles of GitOps, it's declarative, as we said. It's Kubernetes, it's Solo.io, Istio, basically everything's a YAML file. It's all declarative. It's in a YAML file. Love it or hate it, it's there. Versioned and immutable. This is where the Git part comes in that you put your YAML files in Git and manage it like you manage your source code. So it's versioned and each version is immutable. So you've always got that ability to roll back. And then pulled automatically and continuously reconciled. That's where the Weave GitOps platform comes in. It performs that and a number of other things as well, which we will see. So let's have a look at Weave GitOps. So the platform has essentially 4 core use cases. Some of these we'll touch on, some of them we won't. We don't have enough time to go through everything. So we can use GitOps principles for managing Kubernetes clusters themselves. We won't be going into that. We'll be talking about trusted delivery. So this is using a policy as code to actually validate that YAML before pushing it out to your Kubernetes. So to catch all those possible basic typos and configuration foo-bars that are quite easy to do in complex YAML files. Release orchestration, this is really at the heart of it. This is doing that reconciliation, so taking your configuration from that single source of truth in Git and deploying it into Kubernetes. And then there's additional tooling around the top of that, so observability dashboards, so really to give us a view of not only what your deployments are doing, but the health of that GitOps engine. So Weave GitOps is built on top of Flux, which is a CNCF project currently incubating, hopefully soon to be graduated. We're going through the final processes with Flux and the CNCF at the moment. And Weave GitOps is built on top of that Flux core. And at the heart of it, it's that constant reconciliation. It takes what's in Git and applies it to Kubernetes. So that single source of truth in Git, you push a change into Git. When that change is merged into the monitored branch, it is applied to Kubernetes. Conversely, if anybody makes a direct edit to Kubernetes, then the constant reconciliation overwrites that change back to that single source of truth. So no more kubectl apply and other dirty hacks. Your Kubernetes cluster is as it is defined in Git. So GitOps is more than yet just more automation. It actually brings many more benefits. So first of all, enhanced security, because day to day, all the operations are done through Git, through that regular push and merge. There's less need for people to have direct access to your Kubernetes cluster. So you're not giving cluster admin kube context files around the place. Everything is a single source of truth. So what is in Git is how your cluster looks. And because you've got that review and approval via pull requests, so you've got many more eyes on changes as they progress through. And of course, Git gives you that full audit trail, who changed what, when. Because of the automation, it's going to accelerate your delivery pipeline. You push the change into Git, it will get applied. It's automatic, and because you've got that immutable version history, should you apply a change that proves to be maybe less than optimal, it's very easy to roll back to that previous commit, again, which will then get automatically applied and get you out and back, recovered to where you were before. So let's go. So as I said, it integrates in with your workflow. So there's nothing new for anybody to learn. They're using regular workflows, which is what your DevOps team are using day in, day out. They're interacting with Git. They create that pull request. That change gets merged into the management repo. Weave GitOps applies it to your cluster. However, with trusted delivery, this is where we then use the policy as code. We can check those changes as they go through that process. So we can check for things like security. Have we got containers running in as root or privileged? Is TLS enabled? Are we only pulling containers from approved registries? Then we have resilience, so minimum number of replicas. Are all the health probes defined? Are resource limits set? Those types of things. All standard stuff that can be double checked by that policy as code. And finally, coding standards. Most organizations will have some standards around the annotation and labels required for those deployments. We can check that they are both there and that they are set to same values. And those checks can be performed at a number of places. So they can be done on commit or on PR. So as that PR gets submitted, the changes are validated, and you will see then in the PR, you'll get some checks failed. And straight away, you know what you need to do to improve that. That same hook can also be used in your build system. So we can fail a build if the config is no good. Then ultimately, we have the ultimate backstop. We have an admission controller. So even if someone tries to circumvent all these checks beforehand and does that sneaky kubectl apply, then that admission controller is going to catch those any violations, and they will fail to apply. So you've got that ultimate backstop there. And then there's an agent that runs inside the Kubernetes cluster, continually checking for any policy violations. So that gives you that constant runtime check. So this is great if you've got an existing cluster and you bring it in, you can put the agent on that and you'll get a report straight away about any potential things you should be looking at, tweaking and tuning because they are not compliant to your standards. So let's have a, whoops. That went one slide too far. So let's have a look then how that integrates into your regular workflow. Well, basically nothing changes. The engineers do the same as they've always done. They push those changes into Git, do their pull requests, only this time we have policy as code checking those configuration changes and validating that all the YAML is up to spec, that we've got those health checks, that TLS is enabled, and that secrets are defined, all those checks that you want. The system comes with a library of over 100 policies to get you started, and of course modifying those or creating your own is very easy. It's built on the Open Policy Agent and the Rego language, so very easy to tweak and tune or add your own. And of course the policies, it's GitOps, the policies are stored in Git, so managing and maintaining those policies is just that regular Git workflow. So that's enough about Weave GitOps. Over to Dan, who will take us through the solo IO part. Over to you, Dan. I'll just stop my share now.
Thanks, Steve. Let me get my screen up. There we go. I hope everyone can see that.
Yeah, looking good.
Excellent. Thanks, Steve. All right, just a quick introduction here for Solo IO. It was founded in 2017 by Edith. And since then, it's been focused on the technologies, open source technologies like Envoy and Istio to build our products. And these products are GluEdge and GlooMesh. And that forms our application networking platform. Specifically today, we'll be looking at GlooMesh and the Istio service mesh side of things. So the popularity or the success of our products can be seen here, you know, growing customer base, well-funded. We're really expanding and growing quickly. And most of the reason for that is really the people within Solo IO. And here you can see we really have the Envoy and Istio community leadership working in Solo IO, constantly focused on those technologies and how to make that enterprise ready. You know, Lynn Sun is the founding Istio product maintainer. Christian is on the steering committee, technical oversight members. We're really ingrained with Envoy and Istio, and that really is why we are so successful. So let's take a closer look at application networking. What do we mean by that? And really what we are talking about here today is that communication between services, service A to service B. How do we ensure that that communication is secure and has quality of service? So if we think about capabilities that your application networking need to bring, we can see, you know, the list is load balancing, service discovery, timeouts, retries, circuit breakers, transport security, and it needs to be extendable. So we'll notice from this list that they're not really new ones. You know, these are, you know, capabilities that we've been familiar with in application architectures most of our lives. But the difference is that they are now handed off to your application network. So your developer no longer needs to code their service A business logic with these capabilities. Service mesh is decoupling the developer from those requirements, and also your platform operators can now easily set up their policies via the service mesh. And as Steve mentioned, once you start looking at these application architectures in the cloud native and microservices space, things can look and seem quite complex quite quickly. And that is really why it's key that your application networking solution is able to abstract that away from you. And that really is what GlooMesh is all about. Like Steve was saying, that GitOps core is about abstracting away kubectl apply and the Kubernetes API to a large degree. GlooMesh is about abstracting away Istio, really making your complex multi-cluster, multi-mesh environments a lot easier to manage. And GitOps plays a very important role for organizations because they quickly find the benefits that come with service mesh is good, and they want to start scaling that. And that's really at that scale where GlooMesh and GitOps really work well. So few other things that come with a modern application networking platform is the right technology. So GlooMesh, like I mentioned, was engineered from day one using the right technology, which essentially boils down to Envoy Proxy. And Envoy Proxy is open source, very production hardened, distributed systems aware proxy. It's been in production at scale for many years now, and it's really the underlying technology and success of that has allowed us to build our products on top of Envoy and Istio. But also we keep an eye on new trends like eBPF and WebAssembly. It's becoming the de facto way to really extend your service meshes and proxies for niche capabilities that your organization may have that's not covered in our product. So all those capabilities are available in GlooMesh today. It's also bringing that unified single pane of glass to your organization. You know, too often, as we said, you start scaling because of the success of your cloud native architectures, and it goes quickly into multi-cluster, and that becomes really hard for operational teams to visualize and manage and operate. And GlooMesh, your application networking platform, really needs to simplify that and provide a single pane of glass where all these policies are managed, where they can come for their operational requirements like observability and applying their security policies like ZeroTrust. And then, as we've said already, GitOps is now almost a de facto requirement for your cloud native environments as well. As Steve has already spoken about it, it really brings a lot of secure and controlled capabilities to managing your clusters, applications, and platform services like a service mesh. And that's another key requirement of your service mesh. Can it fit into a GitOps model? So if we just quickly go through the list of GlooMesh Enterprise, what it brings on top of, let's say, Istio open source, the key things to remember is the long-term support that come with it. Istio Upstream is N-1, so a very aggressive upgrade and to stay within support, where Solo is N-4. Which gives you about a year to look at your upgrade lifecycle. Really shines in the multi-cluster environments, which organizations really quickly develop into. And then when you talk about multi-cluster, you're talking about application network traffic control between those. How do we, you know, if service A is unavailable in cluster 1, how do we automatically fail over the traffic to cluster B where service A is also running? It needs to be cloud native, and it needs to be extendable by WebAssembly, and it needs that unified observability. And we'll be looking at mostly the observability, the multi-tenancy, and the ZeroTrust in the demo. We'll have a look at those a little bit closer as well. Okay, so let's get into the demo. So for the demonstration, we'll be looking at a couple of the use cases, probably the, I would say, almost entry-level bread and butter use cases for service mesh. And those are, we want to encrypt our transport to TLS, and we want to apply ZeroTrust. So we'll look at those two and how to configure those policies with GlooMesh and GitOps core. And then at the end, we'll talk about GlooMesh multi-tenancy, which is a new feature for our GlooMesh version 2, and also the visualization of your application network. Okay, so if we look at the demo, I have done some pre-prep, of course. I've built 3 clusters, and they just Minikube instances, Kubernetes 1.23. I have pre-provisioned Istio 1.11.7 to that, and GlooMesh 2 beta 17. And then the Weaveworks GitOps CLI has been installed and bootstrapped as well using version 0.6.2. The bootstrap processes, obviously, as Steve mentioned, is also totally GitOpsable. So if you want to have a look at that bootstrap processes, we actually covered it, me and Steve, at SoloCon. So there's a session there with GitOps Core and Glue Edge, and you can have a look at that to see the bootstrap process. We also have that link in the slides, so will be available for you later. Okay, so let's get cracking. Now that we have our environment up and running, we'll get into GitOps Core. I'll run the UI, which is just a port forwarding command in a different terminal, and start adding my policies. So first, I want to add my management server. So start that, and we'll have a look at these a little bit in a minute, how these all fit together. A very, very easy process. I'm pointing it here to my private GitOps repository that contains my policies, my Kubernetes YAML manifests for the policies. So authentication has gone in, and then within that repository, I'm going to say that it needs to look at the management panes folder, and then the GitOps configuration source is in a different private repository, and we can submit that. And it's that easy to add your applications, your infrastructure services, whatever you may be wanting to install or configure in Kubernetes. And we can see GitOps Core automatically creates this pull request. And of course, as Steve explained, the trusted delivery side is important. These controls are important. You know, automation is great, but it needs to be controlled. And you know, GitOps Core integrates the pull request as a control mechanism automatically for you. So I can just go to the pull request that was created, review it. You know, this may be a manager or team member doing this, and we're making sure that no unauthorized changes are being added to our clusters. Okay, so that was setting up the management server. If we come back here, hopefully that will good. Interesting. Second, there we go. Local PC, just a bit slow there. And already we have here the visualization, as we see during the demonstration, which is a great part of the GitOps Core. You know, working with Git is great, but it's not that visual. And we'll see how GitOps Core really visualizes the resources that we have in there. So helping with that human-friendly way of looking at what we're doing. Okay, so next we'll want to add our workload clusters. Let's Let's go and add the workload cluster. Same thing. I'm just going to open up the management UI for that. Let's bring that up. So this time, saying we want to pull those policies for our workload cluster, cluster 1. Again, it's going to the same policies repository. So add that again. Enable the authentication. These are all temporary tokens that you'll obviously have some control over the permissions and how they are used. Again, we just say we want to go to the cluster 1 folder this time, and we'll point it to its GitOps configuration repository, another private repository in GitHub. Okay, submit that. And again, we have the pull request, make sure that everything is reviewed and controlled. So we'll just merge that in. Okay, so let's quickly go back to the slide just to explain a little bit more what I just did. Like I said, we have 3 Kubernetes clusters here. We have 2 workload clusters. And then we have the GlooMesh management cluster where all the control plane and management plane resources sit. And then we have now created the GitOps core setups to push configuration to each of these clusters as well. For the demonstration today, we'll just be using workload 1 cluster, but you do the same for, you know, X amount of clusters that you may have. So this is the environment that we are looking at and we'll be using. So let's just go and look at this. So that's gone in. Okay, good. So that's ready. Like I said, the GitOps process, the Bootstrap process has already installed this environment for me. So all the applications are already installed. Everything is very fast to run. We can see the application is up and running. But the problem with the application for us is that it's in plain text and we want to do the transport encryption. So let's look at how we would use GlooMesh and GitOps to enable that. So everything is YAML manifest. So let's have a look at what that YAML manifest looks like. So we go to our source directory and we have a look at the transport encryption. And this is a GlooMesh CRD, so it's a GlooMesh custom resource, and it's one virtual gateway policy that needs to be configured. And this is, again, the abstraction of GlooMesh in terms of Istio. With this one policy, GlooMesh will go on an Istio level, it will go and configure the gateway resource for Istio and the virtual service resource for Istio. But as an operator, you're only authoring one policy and committing that in. So let's take a look at that. So that's the policy. Then we have our normal, I would say, GitOps customization YAML that we'll be using to enable the policies or disable the policies that we want to use. So that's what we'll do now. Just go to the customization. Policy has already been authored. ZeroTrust. Oh, sorry, the wrong one. not that one yet. Okay, so we've just reviewed the Virtual Gateway TLS YAML manifest. So we say, yep, we're happy with that. Let's enable that. And to get that pushed out, all we do is do a git commit. Okay, so what we notice, as Steve said, is no kubectl apply, no Istio commands, no interaction with the Kubernetes or mesh, really. It's all git. And because GlooMesh is declarative in all aspects, we can configure GlooMesh and that policy this way as well. So let's go back to the application. Oh, sorry, the UI, and here we can see it's already picked up the commit. You know, we can see the commit we made here has been picked up by the source control definitions, and the synchronization has already committed that one as well. And the visualization really helps us show the resources that we're using for this application, the workload cluster. So really good, that visualization. And on the application side, we should now see plain text that's unavailable. If we go to HTTPS, it's just a self-signed cert, so everything's still working. So as we can see here, without having to change anything on our product page, microservice or API code, we've been able to enable TLS encryption. And at the same time, we've configured the Istio Ingress Gateway, you know, lots of abstraction and automation happening for us here in one git command. I want to just quickly also take time here to have a look at the GitOps core side of the repositories. They get a bit neglected since all the action is in the policy side. But if we look at the GitOps core side of it, what GitOps, the bootstrap process, has done is, in fact, created these YAML manifests. And these YAML manifests really boils down to the fact that you will manage GitOps core via GitOps as well. So GitOps core manages itself once it's bootstrapped via GitOps as well. So that's another really cool and key consideration to have. You know, GitOps core is built on Flux, and it's got all its controllers running in the cluster. All of those, as you may customize, we'll be doing that in a GitOps fashion as well. So it's really nice that it's already set that up for us, and you'll be, you know, running it from there. As we then add these policies, let's see, we'll see that it's creating these YAML manifests as well. So the UI, this is a manifestation of the UI form that I filled in when I created the policy for the management cluster. Again, GitOps core goes and creates all your manifests for that to allow management that way as well. So really, really good what they've done here in terms of manageability in the GitOps way itself as well. Okay, good. So we have added security to our application, encrypted all the TLS for the north-south traffic. That's a great step. Another key capability with service meshes is ZeroTrust. And we want to have a look at that quickly. If we look at the Istio architecture, this is a high-level explanation of that and how ZeroTrust is possible with Istio. So Istio, the control plane, has a few components. One of those components is Citadel, which is essentially the certificate authority, its own root certificate authority that Istio will automatically create. With that certificate authority, it will issue certificates to your workloads. And by issuing that certificate to each of the workloads in the mesh, they get a identity based on that certificate. The certificate lifecycle management is all automated by Istio, again, totally abstracted away from any developers or operational teams. Istio manages this. So, you know, a typical default value for that workload certificate is maybe 1 day, 24 hours, and then they get rotated. So very secure, actually. Even if someone manages to somehow get the certificate and private key, you know, it's of no use within 24 hours. So Istio automatically issues the certificate, and that gives us an identity, and all of the services in the mesh get that automatically. And once you have the identity, they are able to authenticate with each other with MTLS. So because they were issued by the same root CA, these services are able to mutual TLS authentication. And of course, once we have authentication, we'll want to apply authorization. So is workload A allowed to talk to workload B? And that's where the authorization policies come in. And that really is the high level nutshell of Zero Trust. You know, day one, out of the box, services are issued identities, and they can use that identity certificate to authenticate. But having that alone doesn't allow them to communicate with each other. They have to be authorized by policy to communicate, and you have absolute control of that. So day one, a typical posture would be to have zero trust, nothing trusts anything else. That comes with Istio day one. So let's have a look at that quickly. So as we mentioned in that slide, you know, we have this root certificate that's being set up. And when we go to a multi-cluster situation, the problem is that although you have product page in cluster 1 and 2, you're not able to authorize them to talk to each other, because Istio will have issued a certificate to product 1 that the product in the other cluster cannot trust, because its root certificate is totally standalone. So again, GlooMesh has gone and looked at this and said, okay, well, let's unify the root CA identity. So GlooMesh will create a new root CA. It will then push intermediate CA certificates to each of the workload clusters, and those intermediate CA certificates are used by Istio to issue the workload certificates and identity certificates. And so we see a normal standard PKI certificate trust being established here, because they share the root and the intermediates that they are using was issued by the same root. Now these services in each of the clusters are able to trust each other if policy allows it. So creating these root certificates, issuing it, setting up Istio, again, all of that is automated by GlooMesh, and that's what we'll see in the next step of the demonstration. So just a quick way to sort of see all of that happening. We can have a look at our containers. So that is our product page book info application containers. And then we also have a few other containers set up outside of that namespace. And we can see here a quick look. We can see 2 containers for this application each. The one container is your application code. The other container is your Istio proxy container that is what Istio is using to set up the policies and control the traffic. And then if we look at this namespace, we have one container which is also in the mesh, different namespace. And we can see that there quickly. And then one that's not in the mesh. And so we'll use these to validate whether ZeroTrust has been applied. So currently, if we look at the Istio, it's just got the default Istio CA available in both clusters. Okay, so let's have a look at the policies that we'll use, the GlooMesh policies, to enable ZeroTrust. So this is a policy that we'll be using. Again, so much abstraction. If you look at this YAML file and look at what that's going to do, really automate all of this setup, it's pretty impressive. And that's you know, the power of GlooMesh again, especially in this multi-mesh and multi-cluster setup. In fact, this part is only included because Istio actually is capable of detecting that a new CA certificate has been made available to it, and it will then start rolling out the new identity certificates to the workloads as well. But that can take up to an hour or so. So we just add this to restart and that process so it happens quicker. Right, so we have our policy and we can go to our customize and say, okay, let's enable that. And we'll just do git push. Now bring up our management UI again. Let's see. This time we can see, still waiting for that commit come through. There we can see it's picked it up, synchronized it into the container, and also the visualization is here for us. We can very easily see what we have, what resources we have running in the cluster as well. Okay, so let's check the application. That's of course very important that everything continues working. That's now the restart of the pods that is happening there. So let's use our other checks until those pods get their new certificates. Okay, so if we now go and check the Estio certificates, bring that up a bit. And here we can see that the new intermediate certificate has been created. So that is now where Istio is busy restarting everything on both clusters that has been issued. So let's have a look. Let's come back. There we are. So everything's still working. And as I was saying, normally Istio will just take care of that. We just forced it with a restart. Okay, so let's take a closer look at ZeroTrust. As I said, we have our application services running in the cluster in a namespace, and we have a few others running in a different namespace. And this is really where the GlooMesh version 2 multi-tenancy comes into it, where we have introduced the concept of workspaces. And workspaces are there for different personas, different teams really, or projects. So for instance, the book info developer team will be only using the book info workspace, and that workspace is stretched across X amount of clusters. Wherever their microservices are running, that workspace is able to be introduced. And again, on the ingress gateway side of things, you'll probably have a platform team that's in control of policies for the API gateway. And so they have their own workspace as well. It's great that GlooMesh is now understanding that this is where organizations will want to, this is how they will operate. And so the service mesh needs to be able to do that as well. So that's why the concept of workspaces have been introduced with GlooMesh version 2. And what we do in terms of ZeroTrust is, as we enable it, the automation will look at where that policy is being applied, the workspace. It will understand that the services in this workspace need to be able to talk to each other, and therefore the authorization policies required to do that will automatically be created. It will ensure, because we still want zero trust, it will ensure that even when a service is in the service mesh, it's not allowed to talk to it unless we explicitly allow that policy. And definitely something that is outside of the mesh also should not be able to access our services. So that's what we'll see in the next part. Okay, so we've created the shared route. It's been rolled out. So let's do a few tests. In the first test, we are going to the not in mesh container, actually into that container and running a call command to the reviews page. And shockingly, we're seeing it is actually getting a 200 response. So not ideal, not a good start for zero trust. So let's do that again with the in-mesh container. There's a bit of a bug on my demo still, so I'm just restarting that one. So now we are doing the same from the in-mesh pod, but it's not in the same workspace, and this time we're getting 200 as well. So we're like, well, that looks like a fail. You know, everything is still communicating with each other. But remember, all we've done so far is actually just establish that root certificate, shared root certificate. So now we will start using zero trust and enforcing it. And it's quite important to see this because most organizations will have their production clusters already, and you can see introducing zero trust and these policies is very controllable. You know, you have complete control on how to introduce it, which parts, very granular, as we said during the slides. It's quite important for your application networking platform to be able to do these things. Okay, so let's now go and enable zero trust. So again, GlooMesh is abstracting away Istio for us. In the background, this all hangs off Istio authorization policies. And as we can see, that there's no policy at the moment, and that's why things are still a bit open and accessible. So if we go back, policies, what we will use now is that workspace concept, as I said, that multi-tenancy, and again, a very simple manifest to enable this zero trust. And with this single policy, really a lot is happening in the background. like I said, it's actually going, understanding all the resources in that workspace across both clusters and making sure authorization policies are in place to allow them to continue operating. At the same time, you know, we now expect these to not be able to communicate after we apply the policy. Okay, so yeah, we are in the management cluster. Let's have a look at the applications one. Okay. Policy has been authored and tested, all the usual stuff. All we need to do is enable it. Okay, good. Let's go back here. We can actually see that's been applied. So the workspace policy is in place now. Okay, so now again, we'll come back to our application. Yes, everything is working. So we know GlooMesh has found the resources that is required to, the Istio resources required for this to continue operating, including the ingress gateway access. That has automatically been allowed and set up. So if we now look at authorization policies, we can see that has automatically been created to take care of that. Okay, so let's go back to our pods outside of the workspace and run the tests again. Right, this time we've seen the out of mesh, not in mesh pod is getting a connection reset. And even the pod that's in the same service mesh, but not in the same workspace, get a denied. And we see a 403, so not authorized. Okay. So a really quick introduction to really powerful entry-level almost use cases to service mesh. You know, most organizations would really want these capabilities for their application architecture. And GitOps really makes it easy to adopt and safe as well. I want to quickly just go to the GlooMesh UI. Again, this port forward command, so I'm just running it in the browser. Open that on a different terminal. Some other. Let's check. Yeah, not seeing it then. So, okay, I'm not going to be able to show that just yet. Okay, so I think that's it from me as well. Thanks for looking at that. I will stop sharing. And we can take questions.
Thanks, Dan. Right. Do we have any questions from the floor?
Right, so there was one earlier on, I think it was during your portion, Steve. The question was, do you support Bitbucket Cloud? I think that's
Yeah, we do. We support a number of Git providers, obviously GitHub being the most obvious one, but yeah, Bitbucket, GitLab, and actually just plain vanilla Git if you're hosting your own.
Brilliant. Okay, what is a ZeroTrust network?
Yeah, so I suppose that's for me. Yeah, ZeroTrust is, as we saw, it's not necessarily a one vendor thing, or you need Istio for ZeroTrust. I think that's another important thing to mention when we talk about that sort of security. ZeroTrust has really come into the foreground in recent times, where the old way of having security at the perimeter no longer is good enough for organizations. People can get through that perimeter and then have access to everything inside of that, what was called the trusted internal network, where ZeroTrust is saying, no, we are implementing a network where nothing trusts anything unless it's explicitly authorized. So what we saw today in terms of Istio and GlooMesh is a layer 7 implementation of that. And organizations will use various mechanisms to implement ZeroTrust networks. For instance, they'll still have the perimeter firewalls. They will also look at Kubernetes and probably CNI level layer 3 and 4 network policies to also implement ZeroTrust at that layer 3 and 4 level. And that's actually an area where our product is also developing into things like eBPF. How can we use GlooMesh as you write your policy for ZeroTrust? How can we automate the implementation not only on layer 7 for the application network, but also on the layer 3 CNI level?
Great. Okay, I'm just conscious of time. We have 1 minute left. So I think we'll park the questions there for now, but I know there's a couple of kind of takeaways which we'd like to share with you. So Steve's just bringing up the slides.
Here we go.
Right. So as we mentioned, Weave Core is our free GitOps platform. If you'd like to try it out, please go to weave.works/core. And we do run regular workshops around GitOps Core as well. So you can visit our events page and sign up for that. And then Daniel would like to talk about his takeaways.
Yeah, just a few things there. You will see me and Steve last week. We were at SoloCon, as I said, to see a bootstrap version of this. SoloCon has loads of interesting information. There are deeper dives into the ZeroTrust that we talked about, that second one there as well. So please go there. Loads of other topics, not just what we covered here today. We have our workshops as well, and this is where we have hands-on workshops that you can join and run through sort of these demonstration type environments and use cases yourself, and learn about Istio, GlooMesh, and all those products. So those are probably the key ones I wanted to call out. People can really get a lot of useful and hands-on information from those two. Thanks.
Brilliant. Well, thank you very much, Steve and Dan, today, and thank you everyone for joining. As I mentioned, we will be sending the recording and the slides over to you tomorrow. Thank you and goodbye.
Thanks,
everyone. See you. Bye.